labeled, but the information will be there. So let me give it a moment or two to, I got one notification. Here's the other. Come on. Okay. I just want to make sure the audio is working. So it's not going to be labeled properly, but the data will be there, and it should be some of a delay. All right, it looks proper. Yep, I can hear it, so I'm going to let that be. I'm going to turn this volume down. So yeah, you can actually watch this. So now, I mean, this is kind of dope in my opinion. Like, let me make sure that this works properly. If I make that full screen, it still looks good. And let me just make sure. Okay, but yeah, this is dope. So like, anybody that's subscribed to my channel, they can pretty much tune in. I don't have the live chat going. I could get the live chat. I just not doing it right now because I'm just, Yeah, and it's working. It's cool. So it's like I'm watching it here. Let me move this over just a little bit, see if I can fix that image. If I go like this, and then if I lock this, and then let's try this, and like that. Now let's see what it looks like. Thank you. That's too far to the left. Let me come back to the right just a little bit. All right, come back. Oh, I locked it. So let's unlock this. It's jumping around. I don't get it. I'm just going to put it right there and let it go. All right. So anyway, it's going to have to do it. Okay. So yeah, but I mean, to me, this is the reason I'm excited about this, because what this means is that honestly, I can be anywhere in the world and still do this presentation. I'm so excited because I know someday, as soon as I fix that to get centered properly, I could be someplace tropical on the beach, you know, and say, okay, class, what time is it? Let's get started. Any questions? You got the live chat. We can interact. I'm like, all right, y'all enjoy your day. And then I'm going to turn it off, and I'm still at the beach. I'm ready for that. So that's me in manifestation. I'm going to let that be. That's really irking me that it's not center, and I can't get it to center. But it was. Let me try one more time, then I'll let it go. What's the other thing? So we got about 20 minutes a section, so we can do it. Let's go ahead and lock. Okay. And we're going to go with this. All right. So, okay. So we want to take about 20 or 30 minutes per section. So this is the second half of Chapter 3 in preparation for an exam over Chapter 3. And then, you know, so be on the lookout for a study guide. Did you ever get a study guide for exam 2? You said it's posted though, right? It should be posted. So the study guide is there. So with my exams, because this is such a time crunch, honestly, if you know my exams, you know, if you know the study guides, you know the exam. For the most part, I would say at least 80%. So because it's such a time crunch, that's why I do this. Now, I'm not guaranteeing, but that's a good place to start. That's a great place to start. All right. That's fine the way it is. Let's go like this. All right. So anyway, let's keep going. So we're here in section 3.4, and let's go like this. Section 3.4, polynomial functions and graphs and things of that nature. Let's kind of look at it. Let's see. Okay, so this is still talking about transformations on graphs. I don't know if you remember outside manipulations. When we do outside manipulations on the graph, do you know how it affects it? Does it affect it vertically or horizontally? Outside manipulations affect it vertically, up and down. So yeah, I'm going to let that be for now. This is a negative ax to the power of n here. So that's not written properly, but I'm going to let that be. I'm going to let all this be for now. Okay, yeah, we can just look at this. So it says graph the function, determine the intervals in which the function is increasing or decreasing. So we have f of x equals x to the 5th minus 2. Anybody know what the original graph of x to the 5th might look like as far as a long-term behavior? In the long term, are they going to go in the same direction or opposite directions? What makes you say opposite directions? Because the highest exponent is 5, which is odd, right? Now that doesn't guarantee that the function is odd, but I'm saying because it's a polynomial and the highest exponent is odd, that means the end's going opposite direction. So one is going to go up, one is going to go down. What is the minus 2 in this context? The constant. What kind of intercept? The y-intercept. So it should cross the y-axis at -2, and in the long term, they should go in opposite directions. That's exactly what we have. Okay, so it's going to be the same as the graph of x to the fifth. It just moves down by 2 because we subtracted a positive on the outside of our function, so that moves it down by 2. Stop me if you have any questions. So what's the parent function here? What's the parent function? X to the power of 6, right? So if a odd degree power function goes in opposite directions in the long term, what do you think the highest exponent being even, what does that mean as far as they're going to go in the same direction, either both going up or both going down. So in this case, because the leading coefficient is positive, both going to go up. Now, if we say plus 1 on the inside, what number is going to make the inside 0? So which way do we move on the x-axis? Left or right? Left. Inside manipulations are horizontal. Because -1 makes the inside 0, we go left by 1. We go to -1. Okay? So it's the same as the original power function x to the 6. It looks something like this. And then we just move it left by 1 unit. Okay? We're actually moving through these fairly quickly. Can you tell me the parent function here? What is it? What do you mean 3? X to the power of 3. So if you know it's x cubed, tell me about the long term. Are they going to go in the same direction or opposite directions? Opposite directions. I see 1, 2, 3, 4. Can somebody identify the 4 transformations here? If you start from the inside, what's the first one on the inside? What is that going to do to the graph? Move it to the right by 1 unit. What's the next one if we work away from the inside to the out? So instead of, you got to kind of separate those. If we say times 2, times a positive 2, how does that affect the graph? Can you tell me? It's going to get larger which way? Horizontally or vertically? Is it inside or outside? Outside manipulations, are they typically, they're typically vertical. So it will get larger. It's going to get larger vertically, so it's going to be a vertical stretch. If we multiply the outside by negative, what is that going to do? It's going to flip it. Which way? Horizontally or vertically? Vertically, because it's outside. I was trying to bait you by going side to side. But it is a vertical flip. So it's still outside, so it's still vertical. If we add a positive on the outside, does it go up or down? Or left or right? Up and down, right? Which way is it going? Up. Up 3 units. Okay, so let's look at this. Give me a color. I think I heard orange. That's okay. All right. So the base function is x to the power of 3. All right, so it's just that S-shaped graph. If we start, the way we do these is from the inside to the out. So this says go right by 1 unit, do a vertical stretch, so all the y's get multiplied by a factor of 2. Then this negative means, since it's on the outside, it says flip vertically. When we multiply by negatives, it flips. On the outside, it flips it vertically. And then if we add a positive on the outside, it means go up by 3. Outside manipulations follow your natural intuition. Inside manipulations tend to be the reverse of your natural intuition. Because for me, when I see -1, I typically think, oh, the negative is the left, but it's the reverse. So the inside manipulations are typically the reverse. Outside follows the intuition. Go ahead. So you do a vertical stretch by a factor of 2, then you flip it top to bottom. So it's the order in which we do these is from the inside to the out. So domains of polynomials are typically all reals unless otherwise specified. Without any kind of manipulation, the domain is all reals. Okay, so if you're working with a polynomial and the highest degree is odd, what do you notice about the long-term behavior of all these graphs? Do they go in the same direction or in opposite directions? So when the highest degree of a polynomial is odd, what's the difference between the statement, the highest degree of the polynomial is odd, and the function is odd? What's the difference between those two statements? Tell me your last name again. Okay, go ahead. I need a more precise explanation. I get 1 or 2 more people. Anybody? Okay, so when we say the highest exponent is odd, that's exactly exactly how it sounds. You look at the polynomial. Sometimes you might have to add exponents if variables are being multiplied, but the highest degree on any term is going to be an odd number in this case. But a function being odd means that it's symmetric about the origin. So that means that if you replace all your variables with, like if you replace x with negative x and you simplify, we get negative f of x. Long story short, that means it's symmetric about the origin. If we rotate, put our thumb on the origin and rotate the top half, it's going to match if you rotate about the origin. So there's origin symmetry. So a function being odd means that it's symmetric about the origin. Whenever you have x comma y, you also have negative x comma negative y. But the highest degree being odd means you look at the exponents and the highest exponent is an odd number. So those are two different ideas. Okay, so I know it's very easy to confuse those. In this case, we're looking at the highest degree of the polynomial being odd. The highest degree is odd. Notice they all go in opposite directions. If the leading coefficient is positive, what can you tell me about the graph? As far as the right hand. If the leading coefficient is positive, what happens to the right hand side? Does it go up or does it go down? Okay, so if you look at the first one, you see the leading coefficient is positive, it goes up to the right. Because the highest exponent is odd, the left is going to do the opposite. Odd means opposite in this case. If you look at the second one, the leading coefficient is negative. That means it goes down to the right. I guess your right is over here. See that? So if the leading coefficient is negative, it's going to go down to the right, and the other side is going to do the opposite. And then similar thought for the last one. Okay, let's keep going. So the leading coefficient really tells you about the right-hand behavior. If it's positive, the right-hand side goes up. If it's negative, the right-hand side goes down. Now, if we're dealing with the polynomial that's where the highest exponent is of even degree, then what can you tell me about the long term? Do they go in opposite directions or the exact same? So the highest degree being even means they go in the exact same direction. If you look at the first one, is the leading coefficient positive or negative? What does that mean about the right-hand behavior? It's gonna do what? It goes up. You see that? The leading coefficient that's positive, the right-hand side goes up. If you look at the second one, the leading coefficient is negative, the right-hand side goes down because the highest exponent is even, the other side does the exact same. Even means exact same. Odd means opposite. That's how I remember that. Even means exact same direction. Odd means opposite direction. Questions, comments, or concerns? Okay, what's the time? Okay, we've got about another 10 minutes. We're moving kind of slow. It's okay. It's going to be what it is. Oh, so multiplicity. So when we start factoring these polynomials, you know how you might have like x minus 2 quantity squared? If it's squared, that means it's going to bounce off of that 0. It's going to hit the x-axis and turn directions. If it's odd, it's going to cross in this fashion. So if it has an odd multiplicity, it's going to cross. Even multiplicity is going to bounce. It's going to be easier to see in action than me explaining it. This is an example that has an even multiplicity. It's going to bounce. These will be easier to see in action. It's tangent, if C is a 0 of odd multiplicity greater than 1. I'm going to let that be. Yeah, I'll let that be too. Turning points. A polynomial function of degree n has at most n minus 1 turning points. A turning point is where a graph goes from either increasing to decreasing, or it goes from decreasing to increasing. Okay? Questions there? Turning points, like, if this is a turning point, how could you describe this like something you see in everyday life, or what kind of shape does this make? We're talking about this. As opposed to like the bottom of what kind of geographical, in geography, the peak of a mountain is a turning point. Or the bottom of a what? Bottom of a valley is also a turning point, right? So if we go from increasing to decreasing, that's like the peak of a mountain, that's a turning point. If we go from decreasing to increasing, that's the bottom of a valley, that's a turning point. So when we look at the graphs, this is what we're referring to. I think we've mentioned this already. For instance, if we look at this one, what's the highest exponent? So because is it even or odd? So the highest exponent is odd. So what does that mean about the long term? Are they going to go in the exact same or opposite directions? They're going to go in opposite directions. Is the right-hand side going to go up, or is the right-hand side going to go down? It's going to go up because the leading coefficient is, and the left side is going to do the opposite. So if the right-hand side goes up, left-hand side is going to go down. Okay? Blah, 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 blah. We have that. That's okay. This is okay. We have this already. We've actually said this already, so that's just a repeat. This is still a repeat. This is still a repeat. This is still a repeat. So this is just reiterating the whole notion of long-term behavior. If the highest degree of the polynomial is odd, they're going to go in opposite directions. If the highest degree of the polynomial is even, they're going to go in the exact same direction. If the leading coefficient is positive, it's going to go up to the right. If the leading coefficient is negative, it's going to go down to the right. The degree tells you about the other end. Okay? Let's see. Based on the previous discussion, match each function with its graph. So if we have x to the power of 4, which one is this going to be? Are they going to go in the same direction or opposite directions? Same direction, so it has to be either what or what? A or C. And then is it going to open up or is it going to open down? Why? Because so what should be the answer? C. Is that okay? Let's try another one. All right, let's see if we can do this one. Now, what's the highest degree? Is that even or odd? So what does it tell us about the ends? Exact same direction. So it has to be either A or C, and then it's going to be A because the leading coefficient is, that means it's going to open, or the right-hand side is going to go down. Does that make sense? See how you look at it and you can quickly pick out? That's how quick some of these questions can go on these exams. But, like, anyway, the way we experience this reality is based on our awareness. So if we're not aware, then we're going to have a hard time. We have to increase our awareness. So A should be the correct answer. All right, this one. If we're looking at it, tell me about the right-hand side. Is the right-hand side going to go up or down? It's going to go up. Is the other side going to do the opposite or the exact same? So which one should it be? Up to the right and down to the left, which is, see how quick that was? You just look at it. See, don't blink. Don't blink. You're going to miss it. We did it that fast. It's over. On to the next one. All right, let's try another one. All right. Does the right-hand side go up or down? The right-hand side goes down. Does the left do the exact same or the opposite? Opposite. So it's going to go down to the right, up to the left. Which one does that? D as in dog. See that? So if it's multiple choice, you already know what's happening in the long term just by looking at it and with awareness. If you're not aware, then you're not going to know. Graphing. I'm just going to give you my own personal rendition of this. So right now at this level, what we have for graphing, first we want to find any intercepts, especially graphing polynomials. We start off with intercepts. We could talk about the long-term behavior. So up, right and left, up and down and all that, exact and opposite. We know that we have a limit to our turning points. I mean, that's enough. Let me see. Now with the intercepts, I typically do the y-intercept before the x-intercept. I found that the y-intercept a lot of times is easier to find than the x-intercept. Sometimes when we're finding the x-intercept, we got to factor stuff, and then sometimes it gives people a hard time. So y-intercept, x-intercept, we could talk about increasing and decreasing turning points. But if we're graphing it, we could talk about up to the right, down to the left. We got our intercepts, and then a few additional points. So we got intercepts. We could talk about long-term behavior, a couple of additional points, and then do our best to connect it with a smooth curve. Okay? Intercepts, long-term behavior, a few additional points, smooth curve. That's usually what I do for polynomials. We have more that we can do, but we haven't discussed it. That's enough for right now. Let's keep going. Find the intercepts. This is still intercepts, and then in-graph behavior. So that's all they're saying. They're saying find the intercepts and long-term behavior. That's all that this slide is saying. Okay, so we're graphing polynomials. First we find the what again? And then take a look at the long-term behavior. Those are the main two things for polynomials that we have right now. So graph. Let's see how quickly we can do this. Give me a color. I think I heard red. Give me something other than red. It's kind of jarring. Okay, I'll do purple. Red is cool, but I'm going to write a lot of it, and this is going to kind of make my eyes feel like they're bleeding. So now, first goal of the intercepts. And let's get a thicker line. All right, so let's look at some intercepts. All right, so it's suggested to start where with the, which one? Y-intercept, right? If we're going to find the y-intercept, what do we do? Set what? Set x equal to 0. So if we set x equal to 0, then we're going to have what? 2 times 0 cubed plus 5 times 0 squared minus 0 minus 6, which is ultimately what? -6, right? So the y-intercept is going to be 0, -6. Any questions there on how we did that? That makes sense, right? Because this goes to 0, this goes to 0, this goes to 0. Only thing that's left is the -6. Let me shrink this down to size because I kind of want to use this space. That's y-intercept. That's why I suggest. That's why I think it's a good idea to do the y-intercept first, because that one's a lot of times easier. It's not always that easy, but most of the time it is. So now, if we can do the y-intercept, we can also discuss the x. So let's look at the x-intercept, right? So to find the x-intercept, what do? Set y equal to 0. Okay. Let's see if we can set y equal to 0. See what happens. We get 2x cubed plus 5x squared minus x minus 6 equals 0. Anybody have a suggestion as far as a technique for factoring here? Suggestions? Yeah, we need to factor. Can we factor this? Does it factor? So we have 4 more terms. Typically with 4 more, we do factor by grouping, but I'm looking at the factor by grouping, and it doesn't look like it's working out. So we need to try to find a 0. I'm going to, let's see. It's definitely going to be at least 1 0. We got the y-intercept. Can we factor this? Let me look at this. What if we put that next to that? Does that help? Because then we get 5x minus 1, and there's definitely not a 5x minus 1 there. And we wrote down the original proper. Oh, rational zeros. Did we talk about the rational zero test? P over Q last time? Yeah. P over Q. Yeah. Yeah, rational zero test. Yeah, we did. So look, we have the rational zero test. Let's do this. So let's go this color. So the rational zero test is this business of P over Q, where P comes from the factors of, I think, the constant term, and Q comes from the factors of the leading coefficient. I think that's the proper order. Is that right? Yeah. So if we, what are the constants here? What's the constant? -6 is our constant. So what are the factors of -6? We have plus or minus 1, 2, 3, and 6. These are things that that divide evenly into 6. Okay. What are the factors of the leading coefficient? What's the leading coefficient here? 2. What are the factors? 1 and 2. So we want to do all the combinations of the top with the bottom, and let's list them out, right? So if we say all of the top, so then we'll get plus or minus 1, 2, 3, and 6. That's everything over 1. Then we want to do everything over 2. So then we get a half. 2 over 2 is what? But we've already done 1, so we don't want any repeats. Then we got 3 over 2, right? And then 6 over 2 is what? But we already have 3. So what we're saying is that if there are any rational x-intercepts, if any of them are rational numbers, they're somewhere in this list. Did we talk about synthetic division last time? So let's try. I'm going to just jump straight to the 0. Now, suppose I didn't know the answer or I didn't have access to the answer. If I wanted to quickly find a 0, I would do the following. If I had a graphing calculator, this is actually okay. If I had a graphing calculator, I would do the following. Hopefully my calculator will load. Let's see if we can get this to load. I really have not used this in a long, long time. I didn't want to have to do all this, but I need it to be working. Calculator. Where is that thing? Here it is. This one. Cool beans. It's not looking all the way there. I want to reload. Is that not the right one? This isn't right. Let me try something else. Browse. Instead of that, this is an 83 plus, where's the latest one? 2011, 2009. What is the proper one? One of these is correct. It's not that, it's not that. It could be this. Let me see, 2009, Firebird. There was a 2011. That's Windows. Let's try this one. I can't remember what I did to get this to work properly. agree. Choose a file, browse. That one didn't work. Let's just try this first one. Nope. So let's trash this. I agree. Choose a file, browse. If it's not the first one, let's try the second one. Error. So let's just reload. It's not the second one. Let's try the third one. 1, 2, 3, I think. And 83 plus. Got a couple more I could try. Yeah. That looks right. Yes. Okay, good. I think we found something that works. So let me reload. Come on. Yeah, that's it. I need to delete the other stuff that wasn't working. Give me 1 second. So I need to go ahead and delete that while I'm thinking about it. Dropbox. Calculator. Shoot. Which one was the one I just used? I don't want to delete the wrong one. I think I can get rid of. Let me delete this. Let me delete. Nope. Let me delete this one. I'm going to let those stay for right now. I don't really need those others, but I'm going to let them stay. Okay. So this looks like it's working. Now, if I were trying to do this one without any support and I knew I had this list, honestly, I would just graph it. If I had a graphing calculator, I would go here, 2x to the power of 3 plus 5x squared minus x minus 6. We are approaching our time limit. I'm going to go to zoom and standard. Just go 10 in all directions, and it should cross. Now, it crossed a couple of times. It looks like 1 should be one of our zeros. So what I'm going to do to verify, I'm going to go to calculate value when x is 1, and we got our 0. So we have 1, 0. That's the hardest part. So now, we have a 0, so what I'm going to do is verify that it is indeed a 0. We can verify it using what? Synthetic division. So let's verify that 1 is indeed our 0. So if we're going to do synthetic division, we got 1 goes in the chair. What are the coefficients?
2, 5, -1.
Do we need any placeholders here? What comes down?
2.
Then what do we write next?
2.
And then what?
3.
7. Yeah, I'm adding, yeah. And then what's next?
7.
And then? And we get our 0, remainder of 0. So that confirms that 1 is indeed a 0. So we have one of our zeros. I'm going to shrink this down. Put it right here. So we know that 1 is a 0. Now we started with a degree 3. At this point, we're now at a degree what? 2. So let's undo, undo, and undo. So we started with a degree 3. At this point, now it is a degree 2. So it's going to be 2x squared plus 7x plus 6. Let's shrink this down to size. So now let's kind of organize the information that we just gathered. So we determined that if 1 is a 0, that means we got to say x minus 1, right? And we get this depressed equation. We get this 2x squared plus 7x plus 6 equals 0. So then, can we factor this now? Are we ready to factor? 2 numbers that multiply to give us what?
7. 6.
Nope. 12. A times C. The leading coefficient is not a 1. So can you give me 2 numbers that multiply to give us 12 and add to give us 7? I heard it. 4 and 3. You see it? So the rest of it, I'm gonna use the box method just for space. I know I probably should make some more space. I know I'm running out, but I'm gonna use this technique. So we said 4 is gonna be a 4x, 3x, and we started with a 2x squared and a 6, right? What do the top 2 have in common? 2x, right? What about the bottom 2? 3. What about the left 2? And what about the right 2? 2, right? So we're going to say plus like this, plus like this. So we're saying that factored is going to become, we're going to have a 2x plus 3 and an x plus 2. Just check it by foiling. So that was a combination of the AC method with the box method. I feel like the box is a little bit easier to see than the AC. The AC can kind of lose people sometimes. I know it's jumbled. Just have to do the best you can. But this is what I mean by the y-intercept a lot of times is easier than the x-intercept because we're still factoring. So now we have it in completely factored form. Now can we identify our x-intercepts? What are the x-intercepts? X equals, from the first one, what's the x-intercept? 1. The second one, -3/2, right? And the third one is -2. Those are the x-intercepts. So we got the y-intercept. So I told you the x-intercept can be a little challenging. It's not always like that, but it can be. Any means necessary you need to do to find those is fine with me. That's legit. We got the y-intercept. We got the x-intercept. What can you tell me about the long-term behavior? Does the right-hand side go up or down? It's going to go up to the right, and then what to the left? Down to the left. Okay. So we can put all together. And then we just choose a few additional points between and beyond these x-intercepts. So like if we got a -1.5, we got -2, -1.5, and 1. Just choose a few additional points. Plot all this up on the same graph, synthesize the information, and you'll see that it'll match all the information that we were doing. You'll get something like this. Okay, it takes practice. So you see how much trouble it gave me factoring and all that. So I know you're gonna have your work cut out for you. So just do the best that you can. This is why I'm making it open notes. This is why, because I know it's a time crunch. Okay, so we did that one. We did all that. You're gonna have to look at it. We're about out of time for this section. I'm gonna let that be. If you're given something like this, you automatically are given the what? Closer. Instead of the y-intercept, we're automatically given the x-intercepts. For instance, what's one of the zeros? -2, 1, and +3. Because you got it when you plug it in, it has to make it 0. So they automatically give you the x-intercepts in this form. Notice, when x is -2, what's the exponent on that 0? It has a multiplicity of 2 right here. What that means, because the multiplicity is even, that means it's going to bounce off of that intercept. The others have an odd multiplicity. This is a 1, this is a 1. So that means it's going to cross. When the multiplicity is odd, it crosses. When it's even, it bounces. Do you see it? When x is -2, if you look at the graph, it bounces. See? Bounce right there. At 1, it crosses. At 3, it crosses. Oh. Okay? All right. So I know it's a little bit of a crash course. You just have to do the best you can. Okay, I'm going to let that be. Let it be. If you need me to go further into details, just email me and I can make dedicated videos that go at a much slower pace. I'm going to let that be. That's fine. Yeah, that's fine. So the x-intercepts, the zeros, the solutions of the equation, and the factors, these are essentially the same thing repeated in different ways. X-intercepts, zeros of the functions, solutions of the equation, and the factors, these are the same thing. We're saying the same thing like 4 different ways. So if we have a polynomial function and we have 2 different y values, if one has one sign and the next y value has another sign, because this is called the intermediate value theorem, because polynomials are continuous, then if one y value has one, like it's positive and the other is negative, it has to cross the x-axis somewhere between those 2 y values, the associated x values. Does that make sense? If you have a polynomial, at one point it's positive, another point is negative, that means at some point in between it has to cross the x-axis. That's the intermediate value theorem, at least once. It has to cross at least once. So for locating zeros. So now, say we have the list of possible zeros, and then we try 2. When we try 2 as a 0, we get a negative remainder. That means the y value is negative there. When we try 3 as a possible 0, we got a positive number. That means, so when x is -2, y is -1. When x is 3, y is +7. So one y value was negative, one was positive. That means the 0 has to be somewhere between those 2 x values. That makes sense? It has to cross the x-axis somewhere between those 2 points. That's how the intermediate volume theorem. So we know that the 0 is somewhere between x equals 2 and x equals 3. Okay, we'll let that be. Let me see. It says if f of a and f of b are not opposite sign, it does not necessarily mean there is no 0. So this only applies when the two y values have opposite sign. If they have the same sign, you're not guaranteed one or the other. You may have a 0 in between, you may not. But if the signs are opposite and you're dealing with a polynomial, you're guaranteed to have at least 1 0 between those 2 points. Let that be. Let it be. What does it say? Satisfies the something, the following, these conditions. No real 0 is greater than 3. All are non-negative. Oh, that's the, what's the name? Descartes rule of signs. I'm gonna let that be for now. This is a long section. I'm gonna let that be. So I'm gonna leave this as an exercise. I think I'm gonna leave the rest for you all to look at. So that was 30 minutes there. We're gonna pause for the cause. I'm gonna switch over to the next section. Let me stop this real quick.